screen. So we're going to do the rest. So we did 2 examples so far of getting 2 different real numbers, and we did the one where we get 1 real number repeated. Now you're going to see the 3rd example when you get not real numbers, imaginary numbers. So for example, this is question 1c. Y double prime 4y prime 5y equals 0. So you start the question the same way. Let m be y prime. M squared would be y double prime. Then this turns into m squared 4m plus 5 equals 0. So here we could use, of course, the quadratic. Negative of b plus or minus b squared 4ac 2 of a. Negative of b, that would be negative 4. B squared, that would be 16. 4 times a, 1, and b, 5. All of this over 2 of a, 1. So you get negative 4. This is 16. Minus 4 times 1 times 5 would be minus 20. And this is 2. Negative 4 plus or minus square root of negative 4 over 2. Now, the square root of negative 4. The square root of 4 is 2. And the fact that negative, we say negative 4 plus or minus 2i. So the square root of negative 4 is 2i. So this is negative 4 over 2 and 2i over 2. This is minus 2 plus or minus I. Okay. So your answer m is minus 2 plus or minus I. So the real part of the answer, we call it RE, is the minus 2. And the imaginary part, we call it IM, would be whatever the number in front of the I here, which is 1. So it doesn't matter if it's positive, negative. We take the value, and it's whatever the coefficient, the number in front of the I is. In case you have real imaginary, your general solution is constant E, the real times t, cosine of imaginary t, plus constant 2 E, real t, sine of imaginary t. The real is negative 2, so you have negative 2t, cosine 1t, so t. Here, same thing, minus 2t, sine imaginary 1t. This here is the general solution to question 1c. So now you covered the 3 homogeneous types, 2 different real numbers, 1 real number repeated, and the imaginary answer. Okay. Now we do question 2. question 2 started with, they give you a solution, y equals e minus t. So they start with giving you a solution, and the question is, does it satisfy the following dE, which is y double prime, y triple prime, double prime, 3y prime, 5y equals 0. To see if this satisfies this, we need to take first derivative, second, and third. The first derivative of this, any e, would be itself times derivative of the exponent. Second derivative would be e times derivative of the exponent minus, and there's a minus, turns into plus. Third derivative of this would be itself times derivative of the exponent. Now we put everything here. Y triple prime is minus e minus t. Minus y double prime minus this, plus 3y prime, so plus 3 times this, plus 5y 5 times this. Does this equal 0? Well, minus 1 is minus 2, minus 3 is minus 5, plus 5, yes, that's a 0. So the answer for the question, yes, this satisfies the dE. So it is one of the answers, or one of the answers for the dE. So now, once you know that this is one of the answers, the question is, can you figure out the other answers? Okay, so we want to solve this completely and get all the different answers. As we always do, let m be y prime. M squared would be double prime, and m cubed would be triple prime. This is m cubed, m squared, 3m plus 5 equals 0. So you start thinking, well, can we factor this? Is this something we could factor? Well, if you think about it, no, not really. You can't really do any grouping or common factor or anything. Sometimes it is possible to factor something with 4 terms, but this one, no. But I already know, we know that y equals e negative t is a solution. So we already proved that this is a solution to this. The number in front of the t is minus 1, so m equals minus 1 is a solution. If m minus 1 is a solution to this, that means that m plus 1 is a factor. So when you, like if you wish to factor this, m plus 1 must be one of the factors, because think about it, m plus 1 equals 0, then m is negative 1. So m plus 1 must be a factor of this. To figure out the other factor, we do long division. So we take m cubed, m squared, 3m plus 5, and we divide this by m plus 1. And that will tell us what the other factors are. We take first term over first term. M cubed over m is m squared. Then we multiply. M squared times 1 is m squared, and m squared times m is m cubed. Now we minus the two equations. This minus this gone. Negative m squared minus m squared, negative 2m squared. 3m minus nothing is 3m. And 5 minus nothing is 5. So we continue. We take first term over first term. Negative 2m squared over m is negative 2m. We multiply. Negative 2m times 1 is negative 2m. And negative 2m times m is negative 2m squared. We minus again. 3m minus minus 2m is 5m, and 5 minus nothing is 5. We take first term over first term. 5m over m is 5. We multiply. 5 times 1 is 5. And 5 times 5m is 5m. And when you minus them, gives you 0. So this is the other factor. So now I know that I can write this as the factor m plus 1 and the other factor m squared 2m plus 5, which is the one we get from here. So we already know that if we set this to 0, we get the first answer, minus 1. Now we need to set this to 0 to get the other answer. Well, you can try and factor this, but again, this is not something that could be factored. So we can apply quadratic. Negative b plus or minus square root b squared 4ac 2 of a. b is minus 2 and a minus becomes positive 2. Negative 2 squared is 4 minus 4 times a, which is 1, times c, which is 5. All of this over 2 of a, which is 1. So we continue with this. This is 2 plus or minus square root 4. 4 times, negative 4 times 1 times 5 would be minus 20. And 2. This is 2 plus or minus square root of minus 16 over 2. Square root of 16 is 4, but since it's minus 16, it becomes 4i. Over 2. So it's 2 over 2, 4i over 2, you get 1, 2i. So that means that you have real and imaginary. Real would be the number by itself, and the imaginary would be the coefficient of I, regardless of positive or negative. Okay, so what's the solution? We know this now, and also we know m could also be negative 1 from the given part. So the solution for yt would be C1e the real answer t, which is the answer that we got by itself, and C2e, real t, cosine imaginary t, plus another constant e, real t, sine imaginary t. A is the real number by itself, so you have minus t. C2. This one we go real is 1, so that's 1t, cosine 2t, plus C3e, the real is 1t, and sine imaginary 2t. So this is the answer for the DE. You could also say, since we know that this is one of the answers, and the number in front of it is 1, we could also say we know C is 1, but it's not that big of a deal if you don't. But the important thing is that this is the final answer for the DE. Good? Okay. We go to the last question, question 3. Okay. Question 3 was giving you a DE equation with initial condition. Y0 is 1 and derivative at 0 is 1. Now the initial condition, as you know, is only there to help you figure out the constant, what C1, C2, and whatever. So we start the process the normal way. Let m equal y prime, then m squared will be y double prime. So this is m squared plus 9. You bring the 9 over, m squared is negative 9. Then m, you square root like positive, negative, and you square root of minus 9. The square root of 9 is 3, and the square root of minus 9 is 3i. But to write this the correct way, you see there is no number by itself, so your real number is 0, and your imaginary number is 3. So real is 0, imaginary will be the coefficient 3. So once you have real and imaginary, you can write the general solution. In case of real imaginary, we know it's a constant E, real T, cosine imaginary T, C2 E, real T, and sine imaginary T. So we plug in the information now. Your real is 0, so this is E0, cosine 3t, E0, and sine 3t. And e to the 0, as you know, anything to the 0 is 1, so your solution here is C1 times cosine and C2 times sine 3t. This is here the general solution. When we say general solution, it means that you have a C and a C with it. But now, they give you initial conditions to figure out what the answer is. So, well, let's see if we can figure out what the value of the constants are. I'll use the fact that y at 0 is 1. So from here, if you plug 0, you get 1. So the answer is 1 if we plug 0. So that would be C1 cosine of 0, C2 sine of 0. Sine of 0 is 0. Cosine of 0 is 1. So now I know C1 is 1. So this yt becomes 1 times cosine, so cosine 3t sine 3t. So we benefited from the first condition to figure out the first constant. We need the second constant, and the second constant, derivative at 0 is 1. So we take the derivative. Derivative of this would be negative sine 3t times the derivative of the inside 3. This one will be cosine 3t times derivative of the inside 3, so 3c2. This is the derivative, and we use the condition that the derivative at 0 is 1. So the answer is 1 if we plug 0. Again, sine of 0 is 0. Cosine of 0 is 1, so that's 3c2, meaning that c2 equals 1/3. So now I know that my solution is cosine 3t 1/3 sine 3t. Now, there is something useful that you could do with all these DE questions. You can double check your work and make sure that you got the right answer. Plus, it's possible that he could ask you to do this. So, we can check to see if this is the right answer. It wasn't required in the question, but it could be. Let's see if this satisfies all the conditions given. So, to check, according to this, we need the function, we need the second derivative. So I'm going to find the derivative of this. Derivative of cosine is negative sine, and the derivative of the inside 3. Derivative of sine is cosine times derivative of the inside 3, and this is 1/3, becomes 1. So this here is the first derivative. We also need the second derivative. Derivative of sine is cosine times the derivative of the inside 3, and this is negative 3, so minus 9. Derivative of cosine is minus sine, and the derivative of the inside is 3. This here is the second derivative, and this is the function. Now let's try. Does y double prime plus 9y equal 0? So you take y double prime, which is minus sine cosine 3t minus 3 sine 3t, and you add it to 9 times this. So 9 times your y. 9 times cosine would be 9 cosine. And 9 times 1/3, 9 times 1/3 is 3, and sine 3t. Does this equal 0? You'll see minus 9 cosine cancels with the 9 cosine, and a minus 3 sine cancels with the 3 sine, so it is 0. So yes, this satisfied this part. So this part is satisfied with our answer. Let's see the other conditions. Does y0 equal 1? So let's plug 1 here. Cosine of 0, 1/3 sine of 0. Cosine 0 is 1, sine 0 is 0, so y at 0 is in fact 1. Let's try the other condition. Does the derivative at 0 equal 1? We plug it here. Negative 3 sine 0 plus cosine 0. Sine 0 is 0, cosine 0 is 1. So the derivative at 0 is 1. And if you plug it into this, 0, sine 0 is 0, cosine 0 is 1, so negative 9. But it's not asked for it, but we proved that this solution is the solution that satisfies everything else. So please review all the different worksheets. You only did 4 of them. And the material covered isn't that bad. And if you count the number of questions you've solved in all of the worksheets, probably 10 questions or 12 questions. So again, not that bad. So I still don't know what time I'm meeting you Sunday. I'll let you know later today. Bye.